Hello survey students, this is John Hannon with a video from chapter 3 of the book. I'm going to go over how I solved example 315 for the the example problems in the section about the law of cosines. Okay. And the text gives three formulas that reference the law of cosines. And it says it applies to problems which either you have two sides, an included angle, or you're only given three sides and you have to solve for the rest of the triangle. So situation A, two sides and the included angle, or only three sides are known. And I set mine up in a spreadsheet. So let's see what they give us in this example. So they give us angle A, or side A. Make him green this time. Yeah, I'll make him yellow. They give us side B, which is 67, and they give us angle C, which is 145 degrees. So two sides and an angle, that's what applies. So what do I want to solve? I want to solve for C, and I look through the law of cosines and I see one right here that says C squared. So I used that formula and see if I can freeze this so I can keep my picture. Okay, so I didn't know how to write C squared, so that this means C squared, and I took A and squared it with the power formula. So you can see there equals power B15, which is the 45. I don't remember if it's feet or meters or if it's said. But it's always good, this is bad, because it's always good to put your units of measure next to the numbers. And the reason for that is sometimes those cancel out just like the numbers, and it's important to keep it straight. But I squared A and I squared B also with the power formula. So 67 squared and 45 squared. And then, whoops, let me escape. So I got those two squares by using the power formula. And then 2 times AB. Right, so I made a formula that multiplied 2 times A times B. And then the cosine of C, which is known, I had to change that to radians. And so I took the cosine in that cell with the cosine function of Excel. Then I simply added those all up and said C squared equals all of those numbers. And I took the square root of that, just like the example shows in the book. I used the square root formula. Okay, and got 107 for C. So now C is solved. So then we just go back to the law of sines to solve for A right here. And we did that in a previous example. I isolated the sine of A, okay, with just simple algebra. Sine of A times this division equals 45. And when I let me back up. To get from here to here, multiply both sides of this equation by sine A. So that cancels out sine A on this side. So I get sine A over here multiplied by this ratio equals 45. Then sine A, to get from here to here, I multiply both sides by the ratio, which isolates 1 over the ratio, which isolates sine A, and puts the ratio underneath 45. So this division equals 186.55. So that's how I got from here to here. The example doesn't show that. Alright, so I simply did this math, 45 over 186.55. And to separate the angle, the A, from the sine function, you have to do the inverse trig function. And this is arcsine, like I showed in a previous video. And you can see here, I took the arcsine of, it says M31. What's M31? Oh, this right here. And I converted that into degrees from there. And I simply rounded it off here. That's basically 14. And B, the way they got B is simply subtracting all the angles from 180. Okay, so I think most people just have problems solving the equation down to here and using this arcsine to get the angle. Hope this was helpful. Thanks.